Okay, so yesterday you reviewed adding and subtracting fractions. Today we want to review adding and subtracting mixed numbers. And so you can see here I have three different examples of some mixed numbers. And simply a mixed number, if you recall, is a whole number and a fraction that are combined together. So we have two different mixed numbers here that we're going to go ahead and add. And um, if you remember the way we did this in class, we are going to simply add our whole numbers. So in this example, 2 plus 1 is 3. And then I'm going to go ahead and add the fractions. And I can add 1/4 plus 2/4, and that equals 3/4 because the denominator stays the same and I only add the two numerators together. And in this situation, I do not have to change anything. They are perfectly fine to leave my answer just like this. So I am good to go. On our next example, we have, I'll keep that there so you can see it, 3 and 2/6 plus 2 and 4/6. And again, I'm going to do this the same way. I'm going to go ahead and add the whole numbers. So 3 plus 2 is 5. And then I'm going to add the fractions. 2/6 plus 4/6 is 6/6. And hopefully you have some bells going off in your head saying, there's a problem here because we have 6/6, which we know is one whole. So I can rename that as one whole. So what I have to do is combine the 5 plus that 1, and that is going to equal 6. So for 3 and 2/6 plus 2 and 4/6, my final answer is going to be 6 wholes. There is no fractions left over. All right. And for our third situation with adding fractions, we have 4 and 6/8 plus 2 and 3/8. And again, we're going to start off the same way that we have, add our whole numbers. So 4 plus 2 is 6. And then we're going to add our fractions. And our fractions 6/8 plus 3/8. We've said that our denominator stays the same, so it's going to be an 8. And we add the numerators. 6 plus 3 is 9. And here we have a different issue that's coming up. Now, up here we had 6/6, which was, we call this an improper fraction. This is also an improper fraction. And I want you to think back to our number bonds. We are going to take this number bond, 9/8, and we are going to break it apart. And we're going to put, each of them are going to have 8s as denominators because that stays the same. So we have 9/8, and we want to try to get our whole. Now, we know that anytime we have the same denominator and same numerator, like we did up in this previous problem, we have one whole. So how many 8s would it take to make a whole? Well, the answer is 8/8. So if I took 8/8 away from the 9/8, that leaves me with 1/8 left over. And so I am going to bring down this 6 because I still have to deal with that 6, but I'm going to add it to the 8/8, which I know, and we always like to put our whole in a whole. That's why I circled that. That's really going to be plus 1. I've renamed it as one whole, plus the 1/8. And so 6 plus 1 is 7, plus 1/8 would be the 1/8. So 7 and 1/8 is my final answer. So those are three different scenarios that you might encounter when adding mixed numbers. Sometimes you can leave the answer the way it is because it's fine. Other times you have to change the improper fraction. If it's a whole, change it to a whole and then add it to what you already have. And then the third situation, we got our whole number, but our fraction was improper, and we can take a whole out of it and still have a little bit left over. All right, so that was 3 different situations with adding. And now what we want to do is take a look at subtracting. So I have 2 problems here, but we're going to do some more as well. And in the first situation, we're going to kind of do this the same way that we did our adding, only this time we're going to subtract. So we have 5 minus 2, and 5 minus 2 is 3. And in this case, we're going to go ahead and subtract our fractions. And again, our denominators stay the same. So I know this is going to have a denominator of 4. But now I have 3/4 minus 1/4. So 3 minus 1 is 2. So my final answer, 3 2/4. And that's a proper fraction. No need to change it. In North Carolina, our standard says we don't have to simplify this, so you can leave it as 2/4. But some of you already know that you could also say that's 1/2 as well. All right. So that was just a normal subtraction problem, and we get our answer that's no need to change it. And in this case, the next one, we have 7 3/8 minus 3 5/8. And if I wanted to, I could go ahead and say 7 minus 3. Well, I know 7 minus 3 is 4, but then when I get to the fractions, you notice that 3/8 minus 5/8. I can't take 5 away from 3, so I can't solve it like that. And so what we're going to do is we're going to solve it a different method. And in class, if you remember, we solved it, and there was 2 different strategies that we solved it with. One was the arrow method, and the other was the algorithm. And I'm going to go through both of them. And, I've always used the algorithm, but the more and more I use the arrow method, I really enjoy that. So first way, I'm going to go ahead and show you the arrow method. And the way that we do this is we're really going to start with what we're taking away. So we're going to start with the 3 5/8. And we want to find out, well, how much will it take to get to 7 3/8? So we're almost turning this into an addition problem. So, and this is where the arrows come in. I'm going to ask myself, well, if I have 3 5/8, how much does it take to get to the next whole number? And that would be 4. And in this case, if I have 3 5/8, I would add 3/8, because 5/8 and 3/8 is 1 whole, and that 1 gets added to the 3 to make my 4. But I'm trying to get to 7 3/8, so I'm not quite there yet. I can easily jump to 7, and I would add, from 4 to 7, I would add 3 wholes. But I'm not at 7 3/8 yet. So I'm going to go ahead and draw one more arrow. And this time I'm going to get to 7 3/8. And I would need to add, from 7 to get to 7 3/8, I would add another 3/8. So I've got to my end number. But what I need to do is I need to add up the 3/8 plus the 3 plus the 3/8 again. So the 3, that's my whole. 3/8 plus 3/8 is 6/8. So I have 3 and 6/8. That's how much it would take to go from 3 and 5/8 to 7 and 3/8. Now I want to check this. So I think my answer, I'm pretty confident that my answer is 3 and 6/8. But I'm going to check it just to make sure. And I could check it by adding. I could go ahead and add 3 and 5/8, and that's this number here, plus the 3 and 6/8 that I got. And if I do that the way we've been doing it, add the whole numbers, 3 plus 3 equals 6. 5/8, go ahead and 5/8 plus 6/8 is, oops, I want to do this in blue, 11/8. And here, this is, we got that same situation when we added. We have an improper fraction. And so I can go ahead and make my number bond out of this. And I know 8/8 is my whole. So I'll put my whole in a hole here. And if I took 8/8 away from 11/8, that would leave me with 3/8. But I don't want to forget about that 6. So I have 6. This 8/8 represents a 1. I'm going to cross that off now. So I have 6 plus 1. Well, 6 plus 1 is 7. And I have the 3/8. And did I end up with a 7 and 3/8? I did. And that's what I started with up here. Okay. So that's using the arrow method. Now I'm going to go ahead and do the same problem using the algorithm, because I know some of your parents are saying, what did he just do, if they're watching this? And maybe you are one of those people who didn't feel really comfortable with the arrow method and you just want to go ahead and just straightforward use the algorithm. Now when we do the algorithm, we set our problem up a little differently. We are going to set it up vertically. So I have my problem set up vertically, and right away you can see that 3/8 minus 5/8, I cannot do that. So there creates our problem. And what we're going to do is we're going to borrow from the 7, and we're going to take 1 away from that. So that leaves us with a 6. And that 1 that I took away, I'm going to change it into a fraction. So in eighths, if you remember, a whole would be 8/8. So I want to, and this is the important part here, because some of you would be ready to go ahead and subtract, but it's not the case yet. We want to rewrite this. So I'm going to clean up all of this work here and rewrite it. So I have 6 as my whole, 3/8 plus 8/8. Notice I put that addition sign there. Well, 3 plus 8 is 11. So that would be 6 and 11/8. So I've renamed 7 and 3/8 as 6 and 11/8. And I'm going to take away the same thing here. 3 and 5/8. All right. So now I can go ahead and say, well, 11/8 minus 5/8. 11/8 minus 5/8. Denominator stays the same. 11 minus 5 is 6. Okay. And 6 minus 3 is 3. And lo and behold, we got the same answer using the algorithm that we did with the arrow method. All right. We are going to do one more here, and just for additional practice. And I should have said this earlier, but if you have some paper, I'd like you to pause this right here and go get your paper, and I want you to actually do this problem on your own. So I want you to pause here, go get some paper, and then we'll continue. Okay, so you've got your paper, you're back, and we're going to go ahead and complete this subtraction problem. 10 3/5 minus 4 4/5. And again, I can take 4 away from 10, but I can't take 4/5 away from 3/5. So I have a choice to do. I can either use the arrow method or I can use the algorithm. I'm going to go ahead and do both, and hopefully you're going to pick the method that you feel more comfortable with. So starting with the 4 4/5, we are going to work our way to the next whole number, which would be 5 in this case, and I would add to go from 4 4/5 to 5. I'm going to add 1/5. To go from 5, I'm going to jump all the way to 10. I am adding 5. And then to go from 10 to 10 3/5, I am adding 3/5. So I need to add up my whole number plus the first fraction plus the second fraction. So the numbers that I placed on top of the arrows are the ones that I'm adding together to get my answer. So 5 is my whole number. 1/5 plus 3/5 is 4/5. So my answer is 5 4/5. Now I'm going to do this same problem again, only I'm going to do it with the algorithm this time. So I'm going to start off 10 3/5 minus 4 4/5. And again, I set it up vertically this time. And I know right away that I cannot take 4/5 away from 3/5. So it requires me to borrow, to regroup. So this 10, I'm going to make it a 9. And I'm adding 5/5 because that 5/5 is the one that I just borrowed. And I'm going to go ahead and clean all of this up now and I'll rewrite the problem. So 10 3/5 is now 9 8/5. The 9 comes from the 9 that here, and the 8/5 is from the 3/5 and the 5/5. And we are taking away 4 4/5. Make sure that, and it's always important, bring that sign over it so you know what you're doing, what operation you're performing. So now I can go ahead and do 8/5 minus 4/5. Well, fifths is my denominator, that stays the same. 8 minus 4 is 4, and 9 minus 4 is 5. So 5 4/5 is my answer, and that is the same answer that we got using the arrow method here. So hope you remember these strategies that we've learned, and you are going to be working with some of those today. So I encourage you, you're going to have to use some paper because this is really important that you don't try to do this in your head, but to show your work. All right, so again, we did some addition. Where's my addition? Oh, it's up here. We did some addition strategies, and we did some subtraction, and we showed 2 different strategies of subtraction. All right, if you have any questions, let me know. I'm happy to help you out as best I can. All right, have a great day.